All right, I think it's on, right?
It should be. Once you push start broadcast, I think it up it and then.
Okay,
Yeah.
It says live, so I'm pretty sure we're good.
Yeah.
Okay, well, I can read the first one on part 2. So it says, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? And then, so some of them are the simple random sample is drawn from the population. The distribution of the sample mean is normally distributed, and sigma is assumed to be known.
Okay. Okay. Yeah, that makes sense. I don't know why I read that differently. Yeah, no, that makes sense. Okay. The question here, it says the graduate management admission test, the GMAT, is used as an admission criterion in many Masters of Business Administration and MBA programs. A BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. Sample mean for these 50 students is 541, assuming a population standard deviation of 32. Answer the following questions. So the first question is, what is the point estimate for the population mean? Okay. Remember what that was? I read that on Tuesday and
No, I know, I'm trying to remember. So the point estimate is usually just the sample mean.
the sample, that's what I was thinking.
Uh-huh.
So 541. What would be the answer there?
Yeah. Yep, 541.
Okay.
And then so the next one says create a 95% confidence interval for the population mean. Show all your work below. So so the 95% confidence interval, that means Z would equal 1.96. And I'm like trying to figure out where my notes are. Okay. So the lower value would be 532.13, and the upper is 549.87.
Okay.
You plug in the plug it in the equation. So
yeah.
Did you get how to do those ones?
Yeah, I understood that. Okay. That's like the one part of it that I got right on this.
Yeah, those. Yeah, if you know if you can figure out what both of those parts are, so like the point estimate and then the, what is it called? The margin of error.
Yeah.
Then you can plug it all in. So.
Okay. Okay, so say that the sample size changes to n equals 100. Compute 95% confidence interval with the same point estimate. So Z will still equal 1.96, right? In that equation. Or am I still?
Yeah, so yeah, it's still 1.96.
Okay.
The only thing that changes is the population.
Yeah. Okay. Oh, if I remember right. Okay, you know what? I need my notes because I don't know what I did with them too. Let me go grab it real quick. Okay. Now, let me see if I can figure this out. Okay, so we were doing confidence interval. Where should I do it down? Okay, so what do we do for the confidence interval now? Yeah, because it's not in my books and I can't remember. I did remember, like, that was the easy thing, but I can't think of it.
So for this one, if you change the n or the sample size,
Yeah.
you're just changing one part of the equation. So remember the equation is x bar plus, or yeah, x bar plus z times standard deviation over the square root of n.
Okay, that's what I couldn't remember. I was like, I remember the standard deviation over n, or over the square root of n, but then I couldn't remember what else I was supposed to compute into this.
So if you're trying to figure out the little brackets, the first one would be x bar minus z, because you're trying to find the lower
Yeah.
one. So minus z times the standard deviation divided by the square root of n.
Okay. So, and x bar is the 541, right?
Yeah, x bar is 541. And then the z-score would still be 1.96 because it's still 95%.
Yeah. Wait. 1.96 times 3.2 plus. Okay, so I'm getting 541 minus. Okay, 547.272, and wait, how did I get?
Yeah, that's the upper one.
Yeah, okay.
And then now
I
you just have to do the lower one, which is minus.
Yeah. Which for some reason I accidentally pushed plus. And then the lower one is 534.728.
Yep, that's what I got.
Okay.
Perfect. So does that make sense?
Yeah, it makes sense. I just couldn't remember the equation, which
I know, there's so many, it's hard.
if you don't remember the equation, you're pretty much useless.
Yeah.
Okay. Yeah, I went to my notes for the equation. I was like, wait, it's not here because my nephew got into my notebook.
Oh, yeah, you're good.
Okay.
Okay, so number 10 says, how does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of sample size 100? So the margin of error increases, right? Oh, sorry.
It decreases.
The margin of error decreases when the level of confidence
Is larger. Right? It decreases when the confidence level is larger, like it's opposite.
Hold on, I wrote it down. Oh, the level, when the level of confidence increases, the margin of error increases. But when the population increases, the margin of error decreases.
Okay. Okay.
Yeah,
So it's
opposite.
at this point, right?
Wait, what?
But is it decreasing at this point because
Yeah, so
you're looking at the numbers?
Sorry, can you hear me?
Yeah, just
Sorry,
lost.
mine turned off for a sec.
Yeah, that's fine.
Okay. Sorry, did you read that next one?
Not yet. I was waiting for you. I was just trying to figure it out what you were
Okay.
on. Okay, so the next one says create a 90% confidence level for the original 50 students. So I just need to go and find what our z-score is at this point. Too many things to open. I can't. Okay. Okay.
So the z-score would be 1.645.
1.645.
Uh-huh.
Okay. Okay, I got it. All right. And then where did my homework go? So just plugging that in. 0.645 times 32 divided by the square root of 50. Okay. Okay, so the lower one is 533.556.
Mm-hmm.
And then the higher one, 0.444, is 548.444.
Yep, that's what I got.
Right.
Okay, so 12 says, how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that you computed in question 11? So the margin of error gets smaller when the confidence level is smaller. So same, it's the same thing. So when you increase the level of confidence, the width of the confidence interval increases too.
Okay. All right. So the next one says the BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy? Okay. So we want.
So this is the n equation. N equals z times standard deviation over n. Do you have that one?
Is it over the square root of n or just n?
It's the n, so it's the margin of error divided by the margin of error.
Okay, but not the square root of it?
No. And then it's all in parentheses and it's squared.
Okay, so it's n equals z times 32 over. I'm confused. Give me that equation again. Let me see if I wrote it down.
Okay, so it's n equals, and then in parentheses, z
Okay.
times the standard deviation over the margin of error, which is m. and then it's all squared.
Oh, okay. See, I did not know this. Okay. So we're looking for n in two different places in this equation?
Sorry, no, the one underneath the equation is m, as in like mom.
Okay, and then the other one is, oh, okay.
N is as in like the population.
Yeah, that's what I was going.
Yeah, sorry, it's kind of confusing, but
It was like, that doesn't work if I have n on both sides of the equation. Okay.
yeah, you're like, wait, what?
Yeah, I was like, wait. Okay, so, and 95%, so it's 1.96 times 32. Was that the standard deviation?
Yeah.
Yeah. And then that over the margin of
Divided
error.
by 5, because it says it gives us that, and they.
That's right. That's why I was going, wait, what? Okay. All right. Now it's easy. Because now it's algebra and I can understand that.
Yeah.
Okay, so 12.544. Is that right? Oh, squared.
Yeah, and then square the whole thing.
Okay, so then n equals 157.35.
Yep.
Okay. So then are we just rounding up to like 157? Because it's, how many people does he?
I got that same thing, but in the answer key it says 158, but it.
Oh, well, that makes sense because like you can't
Yeah.
a third of a person.
Yeah.
So
So
you would want
158.
yeah.
Okay. Cool. So does that all make sense? You basically just have to have those two equations to understand that.
Yeah, it all makes sense to me if I have an equation and I know
Yeah.
what I'm putting in.
Yeah, that's true.
Yeah.
Cool. And then you already did the quiz for that one.
Yeah, and I went to retake it and I can't because
Wait, it won't let you retake it?
no, because I did it like right before it was closing because I didn't have time. So
Yeah. Dang it.
yeah, it was like, well, at least I got half of the points because
Yeah, that's true.
it had
Better than 0.
a whole lot better than 0. So
Okay, we can go to part 2 if we want of assignment or lesson 11.
okay.
This one's a little bit more complicated, but I think I got it. Because it's like getting rid of the z-score and you're using t instead. It's kind of weird, but
Okay. And what is T? Because this is the one I haven't had a chance to look at yet because my kids have been sick.
oh, here, let me look at this. I don't know if I'm going to be able to explain this very well, but let me try. So, okay, so this lesson is about like when you don't know the standard deviation.
Okay.
And so you have to use the SPSS for a lot of it to compute the data, but you can also use a similar equation that we used in the last lesson. So let me see if I can. Maybe we should go. Do you want to go over part 1? Because this kind of describes what it's about.
Yeah. Yeah, we can do that. That'll make it easier for me anyways. Okay. So what does it say we need? Please fill in part 2. Okay. Do you want me to read the first one then?
Okay, can you hear me? Sorry, I think
Yeah. Yeah, you got cut out again.
Sorry, okay. Let me find the right one. Okay, so T distribution is basically is replacing X. I mean, sorry, Z, the Z score.
Okay.
When you don't know the standard deviation. So, but the rules are for this one, it says list 3 characteristics. So it is that it has to be symmetrical, the mean is 0, and it's kind of confusing unless you read the book, but it says the exact shape depends on the degrees of freedom. So the degrees of freedom is n minus 1. So your population minus 1. And if you look in the book, it kind of shows the curve of it.
Mm-hmm.
And it's a bell-shaped curve, but as your degrees of freedom increase, it becomes more of a normal distribution. And when it's decreased, it kind of like goes more flat, and the tails are longer. So,
Okay. That makes sense.
and the last one says there's more area in the tails than the standard normal distribution, which I just kind of said. So. I don't know if that makes sense, but if you look at the book, it kind of shows different samples and it kind of describes what the degrees of freedom are.
Okay. Yeah, I'm gonna go back and read through all this when we're done.
Yeah, sorry, I'm not very good at explaining it.
I need to just have to go back and do it. This is the first day my kids haven't been sick, and they're all at school for their last day of school.
Oh, really? It's the last day?
And it's out in 40 minutes.
Holy cow.
This is the first time I've had any spare time.
Yeah.
All week.
Well, yeah, it makes more sense especially if you if you look at the prep
Uh-huh.
and then look at the answer key and also the book, it all starts making sense. It's really confusing at first. I was like, what the heck is this?
Okay.
But okay. And then the next one.
Okay, so I can read it. Let's see.
Okay.
All right, it says, how many degrees of freedom generally does the T distribution have when it is used for inference for a single mean? Okay.
So, yeah, just like I was saying before, the degrees of freedom is always n minus 1. So the sample size minus 1.
Okay.
So that's like the easiest part to figure out because say you have a sample size of 147, the degrees of freedom is 146. So.
Okay.
And then it says, what is the formula for the one sample T confidence interval? And it's the same equation as the last one, except for you replace Z with T.
Okay, so
it's X minus T. Oh, and you replace because you don't know the standard deviation. So you replace the standard deviation with S, with the letter S.
Okay. Which is like the
It's still the standard deviation, but since we're not given it, we have to figure it
standard
out.
deviation. Just like not for the population, it's for the the test or whatever. I can't think. It's two different names now. Yeah, okay. Oh, cut out again.
Can you hear me now? Okay.
Yeah, I can now.
I don't know why mine always does that. I always have problems with this.
Sorry.
Anyway, okay, so let's see. Okay.
So the next one says, what are at least two differences between one sample T confidence interval and the one sample Z confidence interval that we went over in lesson 10?
So yeah, it's basically when you don't know the sigma.
I was going to say, is it just that you don't know those two intervals? So, okay. And the next one says, when conducting a hypothesis test for a single mean with sigma unknown, what is the formula used to compute the test statistic? I don't know why I can never say that word.
Okay, so 5. So this equation is going to be kind of similar to the other one. But it's t equals x bar minus mu over s, which is the standard deviation, divided by the square root of n. Do you see that equation right there?
Okay.
Oh, look at it.
All right.
And then, does that make sense?
Yeah, makes sense.
Okay. And then, so the last one says, what are the requirements that need to be met to conduct a hypothesis test for a single mean when sigma is unknown? So let's see. So a simple random sample needs to be drawn from a population. X bar is normally distributed.
All right. Part 2. A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. The average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment properties in this area. He randomly selects 15 of his clients who purchased an investment property, and their ages are 27, 35, 38, 49, 55, 58, 56, 50, 51, 45, 46, 56, 49, 48, 38. Okay. And then what are the requirements for creating a 95% confidence T interval?
So that's the same as the question above. So it's selected from it's a random sample. And then also it's normally distributed, which it is.
Okay.
Okay, so this one has like a lot of points in it, but then in the answer, it just has like the brackets of the lower interval and the higher interval. So that's just the one I did. So it says, with the data above, calculate the margin of error and create a 95% confidence interval to estimate the mean age of the clients who buy all investment property. Input the numbers you compute in number 7 of part 1 into the confidence interval formula. Show your work, the t-score for 95% confidence interval. From the t-distribution with 14 degrees of freedom is 2.1448. Round your upper and lower bound to 1 decimal place. But do not do okay, so what I did, you have to do this, well, actually, I did it opposite, but so I'll just do this one first. Trying to see. Okay. Sorry, did you get that equation?
No, you cut out like
Oh, sorry.
what I did for this one. You cut out.
Oh, so you use the equation like we did for the last chapter, but it's the x bar minus t times s divided by the square root of n.
Okay.
And then on the other side you do x bar plus t times s divided by the square root of n.
Okay, yeah, that makes sense.
And so when you put it all in, so x bar is 47 because that's what the mean age is.
Okay.
And then you do minus t, which it gives you that, which is 2.1448. And then you times it by the standard deviation. So you have to use SPSS for this one.
Okay.
So if you go into that, you have to create your own SPSS and then put in all the values.
Okay.
So like put in all the ages like 27, 35, 38, blah, 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 blah.
Yeah.
So do you want to do that real quick?
Yeah, let me see if I can bring that.
And then I can show you how to do the rest.
All right, let's see. Use my program. I just don't like this program.
I can tell you the values if you want, and then you can just put them in so you don't have to keep going back and forth.
Yeah, I just need to find my program, which is.
Okay.
Which for some reason does not look like it's on my desktop. It should be. I gotta go looking for it.
I know, I had to go find mine too. It won't work if you like open up another, like if you open, at least for Macs. Do you have a Mac or do you have a PC?
PC.
Oh, okay. At least for mine, like if you try to open it up with one that you've already opened, it won't let you create a new file. I don't know why, but.
Yeah. And not like in a hidden folder somewhere. And my kids have been using my computer for their finals. It's not there anymore. Okay, I found it. It's just coming up now. All right. Okay. All right, and then I just input them in here.
Do you want me to tell you what the values are?
Yeah,
Or
go
the-
ahead.
Okay, so the first one's 27, 35, 38, 49, 55, 58, 56, 50, 51, 45, 46, 56, 49, 48, and 38.
Okay.
So there should be 15.
Yeah, I see that. Okay. All right, and then.
Okay, so for this, you have to, so you highlight that whole row, and then you push analyze at the top, on the top bar,
Okay, and then
and then you go down to compare means,
there we go.
and then it's one sample t-test.
Yeah, I see. Okay. One over there. And you push OK.
And then it will compute all that data.
There we
And it
go.
will bring up a little box that says one sample test. Did you get that?
Yeah, I got that.
Okay, perfect. So you're going to need that for the rest of these questions.
Okay.
So back to the equation. If you're trying to, okay, let me see. Where am I? You're trying to find S, and this is how you find S. Wait, actually, oh yeah. So that's the standard deviation comes up with all those values. So it's 8.82745. Do you see that?
Yeah, I see that. That's what I was just looking at. And then this
Then you can plug that into your equation.
and n is 15, right?
Yep.
Okay. And then like on this it says the mean is 46.7333, or are we just rounding up to 47? Or does that make a difference?
So you'll use that for the next one, I think.
Okay.
So just do 47 right now.
Okay. That sounds good to me. Now look at my calculator. All right.
Oh wait, hold on. Oh, never mind. Yeah, we're good. So X bar, we're given X bar. Oh, sorry, no, you're right. You do use 46.733.
Okay.
Because the mu is 47, but X bar is 46.733. Sorry, I didn't know the first time, so I was looking at it.
Okay, so we get, it's 46.7333. Minus 4.885. Does it say not to round till the end?
Mm-hmm.
Okay. Okay, so we're looking for like the two different numbers, right? The lower and the higher.
Mm-hmm.
That's 41.845 is what I got. Lower.
Yep.
6.7333 plus 51.622 on the top. When it says to one decimal place, so it's 41.8 and 51.6.
Mm-hmm.
All right.
Okay, cool. Did you get that? Does that make sense?
Yeah, it makes sense a lot more now that I have it all on SPSS and it's in front of me and
Yeah, it's a lot easier with that.
in my head.
And then if you look on your little table, if you look on your table that you put into your SPSS,
Yeah.
it gives you it gives you the 95% confidence interval right there. So.
Amazing. Yep.
Okay, and then the next question, hold on, let me get to. Okay. So basically, we don't have to do all of these. I think a lot of them are just practicing putting in different numbers. But for this one, instead, you would just do for a 99% confidence interval, it gives you the t-score, which is 2.9768. And that's the only thing that you change in the equation.
Okay.
So instead of putting 2.1448, you just put 2.9768. Does that make sense?
Yeah, it makes sense. It just
And
replaces
And you keep everything else the same, and then you figure out what the confidence interval is.
Okay.
So I don't know. Do you want to go through that, or I think
I
that
think
basically
we're okay.
okay. It's the same equation. So
Yeah.
and then for the next two, they're really just the same thing, except for it just asks you to use the software, which we already did. So it asks for the 95% confidence interval and then the 99% confidence interval, which we just found out. So
Okay.
and it gives you them when you compute the data. So anyways. Okay, so I'll go on to a number 11. So it says, how does the margin of error of the 95% confidence interval to compare to the 99% confidence interval? So let me see. So the margin of error increases when the confidence interval increases. And then vice versa. When it's smaller, the confidence interval, or when the confidence interval is smaller, the margin of error is smaller. So
Okay. All right. Number 12. This is rather than estimating the age of his clients that buy investment properties, the real estate agent would like to test the claim that the age of his clients is different than the national average age of 47. Use the 0.05 as your level of significance. Follow the following sequence of steps. Fill in the answers at each step and show your work. So it says state the null and the alternative hypothesis. So the null is that the national average age is 47. The alternative hypothesis would be that the age of his clients is different than the national average.
Yep. Okay, so then it says compute the test statistic. First compute it using the formula and showing your work below. Then check the test statistic by inputting the data into the software. So this is where you have to find out what T is.
Okay.
So the T formula is X bar minus the mu divided by S, which is the standard deviation, divided by the square root of n. So in this case, it would be, so X bar is 47.733, which is what we found out before.
Okay.
And minus the mu, which is 47, divided by S, which is 8.82745, divided by the square root of n, which is 15.
Okay.
Did you get that equation?
Yeah, I got it here.
Okay. So I got negative 0.117.
You got what?
Negative 0.117.
Okay. I did not get the equation down wrong.
Is that what you got too?
No, but yours is right. So I wrote down the equation wrong probably because it's,
So
yeah.
what's the equation that you have?
So T equals X bar minus the mean,
Mm-hmm.
and then over standard deviation divided by the square root of the population.
Uh-huh. That's it.
So is, maybe I wrote it down wrong, where the X bar minus the mean is supposed to be on top, right? And then the other underneath both of those?
Uh-huh.
Yeah. So I don't know why I got it wrong. But, okay. It was close to it, but it wasn't. So
Okay.
that's right.
Does that make sense?
It makes sense to me. I just, in the math one somewhere.
What I don't understand is when you go into the SPSS, it says that T equals 20.504, which doesn't make sense to me. Because when I did the equation, I got negative 0.117, which is what the answer key says too. But then when you look at this T, I don't know why it says that.
Let's see. You know what? I know what I did wrong. I put the mean in wrong. Okay. Oh, you're talking about where the T, it says 20.5? Is that where you're?
Yeah. I don't know why it says that. Weird.
Yeah, I don't know.
But when you do it by hand, I got it right. I don't know. It's weird.
Yeah. I don't know. I'm still trying to figure out this program. Like, this program is.
I know, it's kind of confusing. Okay, so the next one says state the degree of freedom, degrees of freedom. So you just do n minus 1, so 15 minus 1 is 14.
All right. Yeah, that makes sense.
Easy enough.
Yeah. Okay. Okay, so sketch the T distribution and shade the area which represents the p-value. Which,
So then you have to go into the normal probability applet.
yeah.
And then put in the T for instead of the Z score, or in place of the Z score.
And that T is negative?
Mm-hmm. So it'd be
0.
negative 0.17 and then positive 0.117.
Yeah. Okay. And it's just the space between the two red lines?
It's the ones opposite of them, I'm pretty sure. Wait, I think, hold on. Oh, maybe it is in between, actually. Wait, hold on. Oh, no. It's the not in between. It's the one opposite because we were trying to remember what the alternative hypothesis is? It's what's not that. So it's both of those.
Oh, it's what? Okay, that makes sense. All right, so
So then the probability would be 0.907.
yeah, I got that 0.9069. Yeah. Okay. Okay, it says use your software to compute the p-value. So back to SPSS.
I don't know where you compute the p-value.
Yeah, I don't know that either.
Maybe it's just what we did before. But we know the p-value because we did it with the p-value is 0.907,
Yeah,
right?
yeah.
I think.
It's so easy for me to confuse myself in this.
I'm pretty sure that's what the p-value is. It's the probability that it's going to happen.
Yeah, that's what I was thinking.
So that's what I have.
All right.
Okay. Well, so the next one says, state your decision. Do you reject the null hypothesis or fail to reject at the 0.05 level of significance? So since 0.907 is greater than 0.05, you fail to reject the null hypothesis.
Okay. Yeah, that makes sense. Okay, last one there says present your conclusion in an English sentence. So basically what we just said is that because we failed to reject the null, then it would mean that his average age of his clients is the same as the national average.
Yep.
All right.
Cool. Okay, so does that all make sense? That chapter is kind of confusing. If you go back and read it, it'll make more sense, but
Yeah, I think it'll make more sense to me when I can sit down and it helps when I'm able to like have 2 hours to just read and write down everything, like
yeah, it's true.
because this week has been mommy, I need this, and mommy, I need that, and mommy, hold my hair back while I'm over the toilet.
That's terrible.
Yeah.
Okay. So we can do the. You want to start the quiz now?
Yeah. Let's start the quiz.
Okay. All right. So. Oh, there's a T distribution applet. That's cool.
You see, that's nice.
I was just using the X one. Okay, cool. Okay, so, all right, I can read the first one.
Okay.
It says, in previous lessons, we have assumed the population standard deviation was known. In this lesson, we are making a different assumption about standard deviation. Standard deviation, what has changed? We assume, so it'd be 1. We assume standard deviation is unknown.
Okay. Okay, so it says for the next 2 questions, let the null and alternative hypothesis be The mean equals 8, and the alternative is the mean is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample size n equals 9 and computes x bar equals 11 and s equals 6. So the standard deviation, is the standard deviation known? And that is known.
Man, this is hard.
That was the hardest question yet.
Okay, so then it says, what is the value of t? So we just have to get that equation again. T
R minus ms.
So x bar is 11.
Mean is 11 minus 8. 6 divided by square root of 9. Right.
Okay. I got 1.5.
I got 1.224. So this is when I was having problems. Maybe I'm computing it wrong. So it's 11 minus 8 divided by 6 divided by the square root of 9, right?
Uh-huh. Yeah.
Okay. So where am I going wrong? So basically 11 minus 8 divided by 2.
Yeah. So 11 minus 8 equals 3. Square root of 6 divided by the square root of 9 is 2.
Yeah.
Or 3 divided by 2.
So it's 1.5. See, I'm just...
I know, sometimes I have to like separate it out to make sure like my calculator's not doing it weird.
My calculator's going psycho on me today.
Yeah, it's
There we go. Yeah. Okay. Makes sense now. Next question is, use the following values which were pulled from the data file body temp for the next 5 questions. Copy and paste them into your software. Use the null hypothesis. The mean equals 98.6. Alternative hypothesis. The mean is less than 98.6. And the levels of significance, standard deviation 0.05. Did I read that right? Okay. So we need to copy all of this down into the... Eight point 7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 8, 96.9, 98.8, 99.9, 96.8, 97, 98.7, 97.6, 98.7, 98.2. What is the X bar? Analyze, companions, one sample t-test. $98.22. What is S? .92201. So 3.922. Is a t-score. T-score 476. Is the p-value? .922.
Can you hear me?
Yeah, I can now.
Okay, sorry. I don't know why it wasn't working. I was like trying to talk to you. I was like, hey, what the heck?
I know.
Okay, so I don't think the T score is right because for mine it said 476.407.
Yeah, that's what mine said. And so I just was like, that can't be right. Like, it wasn't right in our other thing. So I did the math and I got negative 1.455.
So how do you know what the mean is though?
Because it says, like, the one mean is, the population mean is 98.6. That's the one we're trying to, like, they gave it to us in the beginning. And then,
Oh, okay.
like, on the application, it says that our mean for our data is 98.22.
Got it. Okay, okay. I was like, wait, I don't think it gives it to us, but it does. Okay.
Yeah.
And then how many are there again? What's the?
Well, there's 20 of them.
Oh, 20. Okay. Okay, hurry. Sorry, let me hurry and compute this.
That's fine.
Okay. So you got negative 1.843?
I got negative 1.455.
Oh, shoot.
But maybe I did it wrong again. Let me see.
Square root of 20.
98.22 minus 98.6. Oh. That's why I got it wrong. Okay. Divided by 0.2. 6165465. Now I got negative 1.843.
Okay, yeah, that's what I got too.
Yeah, no, I wrote it down wrong in my calculator, which is why I got it wrong in the first place.
Okay, perfect. So let's see. So sorry, what'd you get for number 6? Let's just make sure we got the right ones.
Okay, so 6, I got 98.22.
Okay.
And then 7, I got 0.922.
Okay, perfect. And then this one is negative 1.843.
Yeah. Now I was lost on this next thing, the p-value. I was trying to figure out. I was like, shoot, where do I find this one?
We're gonna put negative 1.843. And then what's the alternative hypothesis again?
That it's less than. Yeah, less than 98.6. So.
Okay, so then we just want to do the unshaded to the left.
Yeah.
And so the p-value equals 0.0813.
That's what I got. Okay.
So that's greater than 0.05. And so we're going to fail to reject. right?
Yeah, that's perfect. Okay.
Okay, sorry, hold on. Let me see. Where do we do p-value? So 0.0. So failed to reject. Oh my gosh, do we have to do this all over again?
Yeah. I know I was just
You're
gonna
kidding.
I gotta pick up my kids like right now too, so let's do this real quick.
Okay. Oh my gosh, you're kidding. This is crazy.
Yeah. Okay. But we can do it. It's not actually that hard once you get into it. All right. 59, 14, 37, 62, 68, 59, 157, 27, 27, 36, 14, 4, 30, 36, 47, 9. And 61. 21 of them this time. Is that right?
You got 21?
Yeah, I got 21 of them. Did you?
Yep.
Okay, then we're good. Okay, so the mean is 40 minutes. We want to claim their test, so your no is the mean is equal to 40, and your alternative is that it is not equal to 40, and your level of significance is 0.01. Okay. All right, what is the p-value? Oh, let's just start straight out with that.
We just got to find out what t is.
Yeah. Nice. Components. Okie dokie. So our mean is 40.0476. And their deviation 36.35585.
Okay.
Okay, so $40 over.
Okay. Did you get the what t equals yet?
I'm almost there. Just gotta compute it. I just figured out all the stuff. Okay. 40.0476 minus 40. 36.355 square root 20.
It's so small, I can't even see.
I got .00599998, which is basically
Yeah.
0.006.
That's what I got here. It's like so small you can't even see it. If you fill in both the sides, it's 1. Is that what you got?
If you fill in both the sides, I get 0.9956. So it's basically going to be point.
996.
0.0044. Would that be like it for the in between? Does that make sense? Because it's 1 minus what it is if you're on both sides.
No, I think the p-value is when you fill in both sides. So you got 0.9956.
Yeah.
So that's what the p-value is then. I'm pretty sure.
Because it's not.
Yeah.
40.
So you fill in both sides. Yep, that's right. I just looked at the example. Mine, I put it in and it's like 0.006. 0.00. It says the area is 1.
0.006.
For the
Did
T?
You got the student's T probabilities.
Yeah. The area says 1, but
Why say? Well, that's because my. Okay, because it has a spot for degrees of freedom up there.
uh-huh.
Does that make a difference?
Oh, maybe. Does it say how many degrees of freedom? Oh, so we have to put, so it'd be 20, the degrees of freedom would be 20. Doesn't make a difference.
9953 is what I get.
So it's 0.995 then? Should we just put that?
Yeah.
Okay. So
.995. Okay, so the next thing.
So you would reject or fail to
Fail.
reject?
Yeah, I would say fail to reject because it's way over.
Okay.
And it's obvious, like it was kind of obvious from the beginning. It was already like right at 40.
Yeah.
So.
Okay, so the next one says you decide to try another alternative hypothesis. This time U is less than 40 and you keep the same level of significance. Did the p-value increase or decrease? It's going to decrease because you're only using half, right?
Yeah, it should decrease by half.
Mm-hmm.
Okay.
So what decision do you make? It's still going to be like 0.5 something, right?
Yeah, it's 0.49 something. So
Yeah.
I would say fail.
Still fail to reject.
Okay.
Oh my gosh, this is. Now construct a 95% confidence interval for the true mean wait time between births at a hospital. Wait, don't we already have that? We have it in here. We have a 95% confidence interval. It's 23.498 and the upper is 56.596. It computed it for us.
Yeah, that's right. It's in there. 23.498. Well,
Oh, it says to one
419. It says to what?
to one decimal place.
Okay, so 0.5.
23.5 and 56.6.
Okay.
56.6. All right, should we go for it?
Yep.
Okay. I don't really want to redo this if we get any wrong.
Oh, we got two of them wrong.
Wow. Okay, the rest of them we got right.
9 and 10 we got wrong. So we should have rejected the null in number 10. Or did I just write it wrong in that one?
Negative 1.843. Let's put it back in. 8.
What is it?
So what's the alternative hypothesis again?
For this one that we missed?
Yeah.
Oh, let's see.
It's less than 98.
Is it less than or not equal to?
We compute the 0.0401. Oh wait, why did we get that wrong? It's 0.0401. So then, oh yeah, that makes sense. I think we accidentally did both sides instead.
Yeah, we probably did. Okay. All right, well, I gotta go. My kids got out of school like 10 minutes ago, so
Okay. Awesome.
they're all gonna be mad.
Okay, well, thanks for your help. We'll see you on
Thank
Tuesday.
you. All right, thanks.
Okay, we'll see you later.
All right, bye.